Right. So I work with fintechs primarily based out of Bangalore. Been with AWS for the last 4.5 years now. I've probably met many of you during the event, the live event. So today's session is around DevOps and how do you accelerate your product releases. So I don't want to talk about DevOps per se because most of us know enough about DevOps, and this has been in the industry as a practice for quite some time now. But what we'll do is we'll look at how DevOps is practiced in Amazon itself. Being part of the team now, I've had the exposure and experience to kind of connect with how releases are made, and even had the chance to contribute to some product releases and so on in the past. So I'm just going to share some of those practices that we use, and hopefully you all can take away some learnings from this session. So that's going to be the agenda today. Okay, so from a content standpoint, we'll talk about, so DevOps is about culture, tools, and processes, right? And how all of these things come together. So we're going to talk about, the cultural philosophy within Amazon and AWS, and, how do we organize ourselves, and what sort of mechanisms enable us from a culture standpoint. Then I look at two aspects of release. One is deployments and the kind of tools and processes that we use within Amazon. And the second part is, I look at observability also, which is kind of key to some of these processes being successful within Amazon, and we'll dive a little deeper into that as well. And lastly, then we'll kind of bring all of this together into what DevOps means within Amazon, and how it helps. So that will be the content for today. So moving forward, looking at culture, so we'll go back around 20 years and look at 2002, when even AWS was not an organization at that point, right? This is when Amazon was purely a retail business, right? So we had this API mandate from Jeff Bezos at that time, where there was a very clear instruction that went, or a memo that went to software teams, that all teams will henceforth expose their data and functionality through service interfaces. And these teams must communicate with each other only through these interfaces, and there cannot be any other form of inter-process communication. Bezos also said, it doesn't matter what technology they use. So you could be using Corba or EJB or whatever the technology was in vogue at that point in time, but then you still have to build every single application to be externalizable, and so that other teams can use this. So this was a mandate that was there, and even today, to some extent, that kind of has influenced the way Amazon and AWS, in Amazon and AWS, how we build our systems and applications. So how did that mandate lead to how we are building our systems, right? Most of the systems that were there earlier as a monolith slowly converted to a microservice architecture. We had a single purpose system for every service that we were building. All communication was and is even today through APIs. All connections happen through HTTPS, and these are all largely black boxes, right? And due to the mandate, which said that you cannot have any other form of inter-process communication, one service could not actually read from another service's database. It had to go through an API, right? So that essentially led to every service becoming a microservice architecture. So if you look at the 200 plus products that we have that are there as part of AWS, these translate to thousands and thousands of microservices underneath. But just having the microservice architecture is not enough, right? If you look at Conway's law, architecture and organization kind of ties very closely with each other. And Conway's law states that organizations who design systems are constrained to produce designs which are copies of the communication structures within these organizations, right? So if you want to build something in microservices, you also have to be organized in a fashion that enables you to build microservices. So this kind of leads to how software teams are also organized. So we touched upon this earlier during the live event, where I think Gautam covered how we are organized as two pizza teams. So we have a very distinctly Amazonian term, right? The way we organize, and that's what we call a two pizza team. But don't take this literally. It does not mean that you can only have like 5 people in a team that can be fed by two pizzas. What it essentially means is that we have to fundamentally create a little startup of maybe 10 or less people. And smaller teams minimize the need for matrix communication and unnecessary meetings and bureaucracy. So that's the whole idea. This, in fact, helps to accelerate decision making for us. And with less technological dependencies, the teams are enabled to innovate and really rapidly innovate on behalf of customers, right? So you can see, how it drives ownership and accountability. So how do two pizza teams work, right? Within AWS, in fact, we call these as service teams. And these teams actually own the primitives that they build, including product planning, development work, QA, even on-call, right? And you might ask, how can developers do on-call? And they do, and that's how it works within AWS. And on-call actually happens based on rotation. So when you build something, you run it as well. So the two pizza team essentially is a single threaded ownership model over a specific product or service. So rather than maintaining complex systems and having to solve multiple problems across several lines of businesses, the two pizza team can just focus on innovating for their own customers. And two pizza teams do not hand over something that they built for somebody else to run. And the single threaded ownership kind of ensures that the same team is responsible for full end-to-end customer experience and across the entire life cycle of the product and service. So moving on. So what about QA ops? Others, what happens, right? So if you look at the way we are structured, most two pizza teams are just two roles: SDEs who are focused on developing and product managers who are focused on product direction. But there could be larger teams where you have like multiple microservices that need to be stitched together and so on. And there has to be some prioritizing that needs to happen. So we have technical project managers that drive development and help us kind of prioritize what needs to go. And then we also have software engineers who are focused on infrastructure and tooling. We'll come to that because tooling and infra is not something that the two pizza team will handle. And we also have SDETs that are focused on test excellence throughout the organization. Some folks are shared across the org, but if you essentially look at it, the two pizza team is mainly the SDEs who are developing, as well as the product managers who are driving the product. So you'll think, okay, this is like a lot of freedom, and yeah, it is, right? Teams are empowered and they're also held to high standards. So this requires that a two pizza team has the right resources embedded within the team, such as engineering, testing, product, and program management, right? Every team needs to have these skill sets to be within the team, and it cannot be shared across so many multiple services, right? And this kind of helps them to own and run what they build and also continuously improve their service. So in the end, a two pizza team isn't just about the size as much as pushing ownership and autonomy down to the team level, right? It also allows teams to run really fast, experimenting early and frequently, and they can apply their learnings much rapidly, right? And as demands for a product or a services grow, rather than expanding the team to many more members, what we do is we split the teams into separate two pizza teams working on single threaded sub areas. This in fact maintains a flat organization and it still preserves the agility, autonomy, and the single-threaded ownership that made two pizza team work well for us for so long. The other thing that I want to highlight is that there are also mechanisms that you need to bring together when you have this sort of a structure, right? And these mechanisms need to be consistent across all the service teams to ensure the same level of customer experience is what is provided by every single product or a service. So if you look at it, we can think of mechanisms at three-pronged. One is at a strategic level, and this is something that Gautam covered, where we use press releases and FAQs as a way to work backwards from our customers and stakeholders and drive product direction. So I will not go deep into that, but there are two other mechanisms that I want to cover here. One is at an operational level, we use a mechanism called correction of errors. This is very similar to Agile retrospectives that is popular in the industry. And then there is one more that we use often called the operational readiness reviews. And these are weekly reviews that we use. And this again are very critical for new launches and so on. So we look at what correction of errors is. Like I said, it is a mechanism very similar to an Agile retrospective. The idea is you learn from failure. You identify contributing factors to those failures. It's actually a blameless mechanism where you don't look at the person responsible, but what are the factors, the external factors that were the cause for a problem, right? This kind of drives continuous improvement, and it improves the resiliency of the system overall. So what we do, we look at what happened, what data reflects what happened. So the COE is actually extremely data driven. You got to have a detailed documentation of a problem and then look at how you can improve it. What is the impact on customers and the business? What are the contributing factors? This essentially is actually a root cause analysis where we ask the 5 whys, just like how Toyota's lean method does. We ask 5 whys to get to the root cause of most problems, and then we document the lessons that we learned. And this is also published across the organization. So every time there is an issue that happens, just to make sure that does not get repeated elsewhere, the correction of errors process has an output that is clearly documented and it's available for everybody else. So that's the first mechanism. The second one is what I spoke about as something that is being used for launches, right? Not just launches, even for keeping something in production with the lights on. This is important. So the operational readiness review looks at questions, and you can look at it like it could be a high or a medium or a low criticality question, but teams come together every week to question themselves on multiple things. So for architecture, you would have a question like, what are the forecasted estimates for customer demand for this service? And have you tested services to ensure that they can handle estimates, right? So this is a question that you need to be continuously asking yourself, right? And this in turn, the answer to this question will in turn drive the architecture of your systems. Similarly, you have a question like, do you have a retry backup strategy for each of your services dependencies? This is very basic, right? And you may have a question like, if your service suffers a data loss, do you have a defined RPO? Now, this in fact drives things like, what sort of backup do you have? How frequently do you need to back up, and so on and so forth. And you need to continuously ask this question to yourself because things can change and architecture also needs to change appropriately. So this is around architecture. Now let's look at some questions for, let's say, release quality and procedures. You may have a question like, what mechanisms ensure that all code changes are reviewed and approved by someone other than the code author? So this has to be absolutely there, right? So if you look at Amazon, every single, we'll come to this a little later, but every single code has to be reviewed by somebody before it can be merged into the main trunk. So it's something that you need to ask yourself as well, to make sure that your release quality is up to the mark. Similarly, you will have questions like, do you have do your deployments automatically roll back incorrect deployments before they breach SLAs? So this is again, it ties back to a certain mechanism that we have where every single deployment is automated to production. It is a continuous deployment model, and you need to have, your service needs to have deployments that can automatically roll back. So when you ask these questions, you start thinking in terms of what underlying mechanisms that you need to put in place so that you meet these requirements. Similarly, a question could be, how is traffic diverted from a host before shutting down the process, and so on, right? So this is again, this ensures that release quality and the procedures meet a certain set of requirements, and this can vary. This can vary by team, right? But you have to define this for your own team and make sure that these are looked at when you do your operational readiness reviews. Looking at one more aspect of it, this is purely incident and event management. This is after you have made your release. Now, how do you handle incidents, right? Do you monitor an alarm on CPU utilization, memory utilization, right? What automated alarms does your system have? Do you even have any alarms? And if you have an alarm, what sort of runbooks and procedures do you have so that your team is able to investigate and troubleshoot each, right? If you don't have these runbooks, can someone in the team, actually handle an incident when it happens? Or if, let's say, a person who is able to handle this incident, if that person is not available, is somebody else, can they come in and handle the incident? And that's what runbooks and standard operating procedures help us do, right? So this is again another way of looking at operational readiness, and this is from an incident and event management perspective. So many of these things that I spoke about is also documented well as part of the AWS well-architected pillar for operational excellence. So if you are on AWS, or even if you are not, it would still be useful for you to look at the operational excellence pillar and look at what questions are being asked and how you can utilize those questions to improve your own operational readiness, right? So essentially, at the end of the day, if you look at the Two Pizza team, it's the responsibility for the Two Pizza team is they are responsible for their product alone, and they utilize a few mechanisms like the PRFAQ, the COE, and the ORR to ensure that there is seamless communication between the team members, and they're able to deliver their products for their customers with the best experience possible, right? And they are not responsible for a whole lot of other things that are there on the right hand side. So they're not responsible for deployment, CI/CD tools. None of the tooling is the responsibility for the Two Pizza team. These are all provided by the rest of the organization. So we'll come to that. So now we do have developers organized in a certain way, and they are now ready to build microservices. But where do the tool comes from, and what sort of tools come from, and how these developers or the Two Pizza teams will be able to deliver their product to production is what we will look at next. So we will look at deployments as the first part of the tools and processes that exist at Amazon. So before we adopted continuous delivery and deployment at Amazon, developers had on many teams had this. They had this team role called a release captain. This was before the CD used to happen, and the release captain was responsible for coordinating the release of code changes. There was a lot of work that went into coordinating each release, scheduling the release date, determine which changes need to be in release, assigning a release number, and so on and so forth, right? But now code changes at Amazon are continuously deployed. as of now. And what this means is a change is picked up by the CI/CD pipeline and is on its way to production as soon as a code review is approved and merged. And most teams at Amazon practice trunk-based development, where developers make code changes through frequent small commits to a single shared branch, instead of infrequently merging a large set of code changes to a shared branch from feature branches. So feature branching was something that, I mean, even I used to do this, where you specify all the different features that need to go into a separate branch, and then you take that and merge that into the main branch before you make a release, right? The problem there is the atomicity of changes that goes into production is still a large set of features, and it's very difficult to debug and do many of the things that you will see that we are doing here. Things like multiple in-flight releases, mutable artifacts, and so on and so forth. So today, our CI/CD pipelines automate the coordination of multiple in-flight releases across production environments. And this is essentially done to minimize the time that code changes spend waiting to be deployed into the pipeline. So as soon as a developer merges new code changes into the main branch, a new release is built and it starts progressing down the pipeline. Since developers frequently merge new code changes when practicing trunk-based development, often multiple releases are built and enter the pipeline every single day, right? And the pipeline creates a new immutable deployment artifact every time new source code changes are pushed to the main branch. So the pipeline then keeps track of which source code commit the release artifact was built from and which environments the release artifact has been deployed to, right? And because the pipeline keeps track of all these relationships, developers don't have to do any of this, right? And our operational practices actually prioritize mitigating an issue first. So what we have also implemented is something called ECN automatic rollbacks, right? So as soon as there is an issue that hits production, what we do is we just roll back. What we have found out is that rolling back any recent deployments prior to start of an operational issue is frequently the fastest path to mitigation, even before we have determined whether any code changes in those deployments triggered the issue or not. So spending time to identify which specific code change triggered the issue or working to get a new code change deployed to fix the issue prolongs the impact to customers, right? So instead, our first action is always rollback, and then look at what caused the issue. So if you look at it, this is kind of standard across the industry with a few changes. We have a source, and then there is a build stage, and we have alpha, beta, gamma stages, and then we roll out to multiple regions. If you look at AWS, we have this complexity of multiple, like 25 plus regions, and then also availability zones and so on. So it may be slightly different from what's the pipeline for you, but big picture, you still have source build and production stages, right? Source build, pre-prod and production stages. So we'll go into that next. So let's look at source and build, right? And any typical microservice, it might have a application code pipeline, and infrastructure code pipeline, and OS patching pipeline, and so on and so forth. And what happens is having multiple pipelines allows us to move separate changes to code into production compared to bringing all of this into one single pipeline. And if you look at source, you have application, operator, tool, test source code, infra, and so on and so forth. And it will also have configurations. And the build stage usually compiles the code. And we have things like unit test, static analysis, code coverage check, and code review checks. So all changes going to production starts with a code review, and it must be approved by a team member before merging that into the main branch. At Amazon, we call this mainline. And the pipeline enforces this requirement. and it makes sure that all commits on the mainline branch must be code reviewed and approved by a member. And the code review is not a complicated process because the changes that go into production are actually fairly atomic. So any other team member who's not the author can actually look at it and just make sure that certain things are met. So with a fully automated pipeline, the code review is actually the last manual review and approval that a code change receives from an engineer. So the code reviewer actually reviewers, they evaluate the correctness of the code, and they also evaluate whether the change can be safely deployed to production, right? They evaluate whether the code has sufficient tests. They will check for unit tests, integration tests, and canary tests. Whether it is sufficiently instrumented for deployment. It needs to have logging, and we have standards for logging as well, so that the output of the logs that we generate can then be monitored and can be alarmed on to do to kind of roll back the deployments if there is a problem in production. So the code reviewers also need to check whether the code is sufficiently instrumented for deployment monitoring, right? So that's one of the key things that you will notice is different when you're using an automated pipeline and rollback as compared to the normal DevOps process. So moving forward, next comes the test stage. Again, we have stages called alpha, beta, gamma, and gamma has two stages. One is called one box, and there is a full deployment. So before deploying into production, the pipeline deploys and validates changes in multiple pre-production environments, right? And alpha and beta, we validate the latest code functions by running functional API tests. And these are like functional tests as well as integration tests. And in gamma, what we do is we validate both functional and both code that is functional, and we also make sure that it can be deployed to production. So gamma is actually a production-like environment. And it includes the same deployment and configuration. It has the same monitoring and alarms, and the same kind of continuous canary testing that we do as production. And gamma is many times it is deployed in multiple regions. So integration tests actually help us to automatically use a service, just like how customers may be using this, right? And these tests exercise the full stack of APIs, and it actually gives us feedback in terms of how the service would behave when you're running it in real production. So one more thing to look at, because I spoke about looking at automatic rollbacks, right? That's something that we do when you deploy something into production, and if it is not working, you should have the ability to also roll back easily, right? Now, whenever there is a protocol change, or let's say there is a schema change in the database, or there's a protocol change in the API itself, you need to do something different to make sure that you can roll back. And this mechanism that we use is called a two-phase deployment technique. So I'll give you an example here. Let's assume that you have a service that just reads and writes XML as a service which is in version 1, and now you want to change it to something that reads and writes JSON, and the protocol has completely changed. Now, if you want to be able to roll back this easily, automatically, you need to have a two-phase approach, and this is what we do. So we go through a prepare phase where we have a V2 and then there's a V3. In V2, we make sure that the service still reads and writes XML, but it also reads JSON, right? So in this case, what happens is you are catering to both the V1 functionality as well as V2. And then there is an activate phase where then you move to a version 3 where now you read XML and JSON, but you write JSON. But this was the feature that you are looking for, right? You want to read and write JSON. Now, even if there is a problem with this version in production, you can roll back to V2 without impacting any of the users that were originally using the V1, the V2 kind of mechanism, right? So because this supports both the protocols. So the assumption here is that for prepare, we assume that all servers complete the prepare phase and then come into the activate phase. And in activate, what we also do is we cannot safely remove the software's ability to read XML. We cannot remove this ever, because in the past, if you had written XML to the database, and there is always the possibility that XML exists, right? Unless you completely rewrite that with a new format, XML will still exist, and you still need to provide this functionality to be backward compatible. So that's the approach that we follow. That's again, it's an interesting takeaway for many of you if you were thinking of doing automated deployments and rollbacks. So again, in test, I just spoke about one box, right? So this is again a strategy that we use. Whenever we deploy, before deploying into production, we need to ensure that the latest code is backward compatible and can be safely deployed alongside the current code, right? So what we need to do is to detect whether the latest code writes data in a format that the current code can pass, and so on and so forth. So the one box stage in Gamma, where you deploy everything in one box, it's like the smallest unit of deployment, such as, and it could be like a single virtual machine or a single container and so on. But it's deployed in that one box, and you have a load balancer route that is sent to that box to ensure that it is working correctly. And there is also a bake-in time so that we keep it there for a certain period of time for every service. And then we move the entire fleet into version 2. So that's something that we do for all our releases. So once the one box is then tested, then we use a rolling deployment feature. So because we also have this concept of availability zones within different regions, we have this ability to actually just launch most of our features in just one AZ and not launch those in other AZs. So we use AZs as a way of deploying certain features to a smaller subset of users, and then to ensure that the software is working well. And this kind of helps us move forward without taking too much of a risk, right? If you just send 10% of your users to a new feature that you deployed, only that much of an impact is there. And then once you have enough baking time and you made sure that the service is running well, then you can move to other AZs and then roll it out to different regions. So this is again very specific to Amazon or AWS, because we have around 25 plus regions. We also kind of move our releases through multiple waves. So you would have like a one box testing in wave 1, which is just one region, and then we move to production in one region, and then we'll go to a second region, and then we'll do a one box and product there, and then we'll be having other waves where we are releasing to multiple regions at the same time. We cannot do this sequentially for every region, because if you do that for 25 regions, it will take more than 30 days for us to develop or release every single feature. So beyond a couple of waves, what we do is we kind of combine multiple regions together and deploy features onto those regions simultaneously. So that's on the deployment. Now, how do you monitor and automate the rollback that I mentioned, right? So when you have automated deployments in the pipeline, we don't have a developer who is actually watching each deployment to production and then they're checking the metrics and they're not manually rolling it back, right? Everything is automated. So these deployments are completely hands-off, and the system actively monitors alarms to make sure that these are all in good stead for that change to be in production. So some examples here that you can see is P50 latency or P90 latency. or even P99 latency, or memory usage, and so on. And if you have an alarm that gets triggered in production for any of these, it gets automatically rolled back. So again, we have similar alarms for one box and so on and so forth. So this is again a technique for you all to use to implement automated rollbacks. And this also ties back to the fact where I said every change that you are deploying should be instrumented appropriately as well, right? And that's because the alarms heavily depend on how well your code is instrumented for it to be able to raise this alarm. Lastly, security. It's again job zero at AWS. So and Amazon. So we kind of include, I mean, security also as part of every single stage. So if you were at a pre-commit level, you're a developer, we have pre-commit hooks that check to make sure that we're not making any mistakes when it comes to security. We don't have any keys. We're not checking in some account numbers and so on and so forth. We implement static application security testing when you commit code into the pipeline. We have software composition analysis. We do application security testing in the test environment. We do penetration testing in the pre-prod environments, and we also do penetration, event monitoring, and so on and so forth in production. So again, just to kind of reinforce on security, just to make sure that everything, all your stages have some aspect of security being tested, and make sure that the final code that you are deploying to production is ready and it is secure. So that's on the deployments front. So we'll now look at observability, right? So we just looked at how alarms are built and how we used alarms to be able to automate deployments and even rollback to ensure that you can really have really fast release cycles, right? So observability is a key aspect of the DevOps cycle here. And what we are essentially saying is that we should have the ability to observe customer experience, right? It's not about your systems and your services and whether there is something wrong there. You have to have the ability to see what the customer is feeling. And as an operator, you should be able to see that through multiple mechanisms, right? And so the errors could be two, right? One is service-related issues that is no fault of the customer and something to do with the service itself. And the second could be something that is customer related also, because the customer is actually sending, say, an erroneous request, like a client is sending a wrong request. You should have the ability to actually see issues in that as well, right? So both of these combined is what would become the observability needs for your organization. So what are the three things that we do? We look at metrics, we look at logs, and we look at traces. And if you look at AWS, there are specific services that address each of these. So if you're on AWS, you look at Amazon CloudWatch for logs. You could look at CloudWatch for metrics, and you could be using X-Ray for traces. But essentially, these are the three category of tools that we use to deliver observability for our internal teams. What we'll do is we'll look at some best practices that we use internally that allows us to not just use the tools, but go beyond and have the ability to actually see how customers are experiencing our services. So the first thing is actually to make sure that you propagate trace information. So here the idea is, since you're building a distributed system, you need to have the ability to see what is breaking where. And the only way for you to be able to do that is if you send an ID that is logged at all layers of your system. It could be starting with the load balancer to your front-end APIs, to the front-end code, to any queues that you're using, to a database, and so on and so forth, right? So that's key to observability and tracing, right? So that's number one. Second best practice that we use is we build a lot of dashboards for our team to look at. So this could be just customer experience dashboards where we see latencies of APIs and so on. We build system level dashboards for every single microservice and API. We build dashboards for our backend microservices. We also build capacity dashboards for the infrastructure on which these are hosted. So what this does is it allows someone who's trying to find the root cause to kind of drill down really fast, and also look at services and look at the product or look at the service from multiple dimensions. And this helps our this two piece a team, which is also doing ops, right, to quickly identify the issue and figure out what are the causes for certain negative experiences for the customer. Third, we make sure that everything that we log or metrics, they are multidimensional. So one way to look at latency could be, let us say we have a service called product info service, and you're logging latency, but that doesn't give you anything useful unless you know which service or which operation within that API is the cause for latency, right? So one dimension that you could potentially be adding is something called operation, and the operation could, and within the operation you could be logging the type of API or the name of the API itself, and this allows us to look at very specific areas of the service and understand what is causing a lower latency or an error and so on and so forth. So again, we use a format called EMF. It's again open. The embedded metrics format is what we use, and this is also used within CloudWatch logs. And this kind of format is what you would see that our services are logging to ensure that we are able to get the necessary visibility. So logging dimension is one thing, but what is the cardinality of the dimension is again something that we focus on. So metrics could be latency and errors, and dimensions could be at a very high level. It could be availability zones. It could be the name of the API. It could be the product name, the name of the method, and so on. But you could even have very low level or very extremely granular dimensions, and these are called high cardinality, right? If you are logging every customer ID, now you have visibility which is unprecedented in the logs, but you also need to understand how and where will you use these high cardinality metrics, right? We look at an example here. So if you have these sort of matrices, the high cardinality dimensions, you can look at things like latency and identify what are the top 10 contributors, what are the top N contributors for low latency, for example, right? You could identify which of your customers are actually having this very specific problem and so on, right? You can find top talkers and understand who and what is impacting the system performance. You could even build your own rules and use that to kind of analyze the logs that you're actually written into the system. So you can use contributory insights to. So this is actually a feature that is available as part of CloudWatch, and we also use this for building our internal systems. So you can use this to analyze the log data and create time series that display the contributor data. You can see metrics from about the top N contributors, total number of unique contributors, and their usage, and so on. It also helps you, find top talkers, like I just mentioned, and it allows you to kind of go a little deeper. This example actually looks at actually partition keys within a database, like a DynamoDB database, and it allows us to actually look at which specific partition is causing an issue with throughput. So something like this can be easily done by logging very high cardinality metrics. So again, going a little deeper, you dig even deeper with log analysis, right? This again another best practice that we use. Now, logs, one way to look at logs is, and metrics is to look at average times, but usually averages kind of are not good, and percentiles are much better to isolate anomalies. So in a normal distribution, so 95% of the data is within 2 standard deviations, right? And it won't be good enough. And any data that falls outside 2 standard deviations is actually an anomaly. So an example here is page load that we are seeing. Now we can see that if you look at the P99.7, we see that it's taking 24 seconds for a page to load. But if you look at the average, it is just 2 seconds. Ideally, for anyone to have a good experience for a page load, they need to have below 2 seconds, right? So looking at something like this with a percentile helps you identify what the end customers are experiencing. Even though there may be a small number, you still need to make sure that everybody has the right experience, right? So this sort of analysis of percentiles enables you to do that. The second part here, what you can see is there could be certain events where if you simply log average data, say even over a minute, it could kind of give you false information where what happens is something at a granular second level. For example, if you're having a use case where you're getting events from, let's say, an IoT set of IoT devices that's coming into your system. Now, if you look at it from a per second level, you may see that at the first second of every minute, there is a huge spike of number of events that is causing your APIs to throttle. But at the same time, if you look at it averaged over a minute, you may not be able to see this. So CloudWatch essentially has some features that allows you to kind of slice and dice and query the logs at different bin levels. And this kind of helps you identify issues that could be possibly there that you cannot normally see. So again, dig even deeper into log and analyze the logs, again, a best practice. Next is looking at raw logs. Many of us do this. It's probably the first thing that we do sometimes. And this is good for errors. And let's say you want to see an error and, I'm seeing errors talking to DynamoDB and what did DynamoDB say back. And you can go into the individual log and see in what exceptions were raised and so on and so forth. And the last thing that you could potentially do is analyze using a profiler as well. So this is again a best practice that we often use. So if you were to use something like Code Guru, for example, you could identify issues within the code that you're pushing. This could even be done static or even at runtime. And this kind of helps you identify issues with latencies and so on and so forth that usually will not be available as part of your logs and metrics that you normally build. So those are some of the best practices that we use from an observability standpoint. Something that you could also take, and hopefully it gives you some ideas, and it can improve the way you are also looking at your own systems. So kind of trying to bring all of this together, essentially what DevOps means, there are three things, right? There's a culture, there is a set of practices, and there are a set of tools. The cultural philosophy is all about tearing down the barriers and make sure that teams are spending time and making smart decisions. You're assigning ownership and accountability to people who are the most directly involved with the product. And you're also increasing the visibility in terms of big picture, and they're able to see the results of what work they're getting done, right? So that's from a cultural standpoint. Practices, you have to build continuous integration and delivery if you want to really accelerate your releases. Make sure that you have infra as code. I think we didn't cover this enough. when we are looking at deployments, but every single pipeline also has infrastructure built as code, and all of that is an immutable artifact. So what it helps you do is you can simply throw away a deployment and roll back to something which was running previously, and you don't have to worry about doing any of this manually, right? Build self-service environments so that you don't have procurement blockers, right? So if you're building a pipeline into which developers can easily push your code in, and the entire pipeline is automatically built for developers, they don't have to worry about procurement and so on and so forth. And lastly, using microservices, again, a great practice. This allows you to kind of break down complex applications into really small ones, and make sure that the teams are kind of also aligned well, and you're able to get your releases out much faster as compared to building monoliths. Lastly, from a tools perspective, make sure that you have a good deployment pipeline, development and deployment pipeline. Make sure that you have the right configuration management and application management tools. Ensure that you have the right observability tools as well. You should be able to do your logging well, build metrics out of those logs, be able to build alarms so that you can even implement things like automatic rollback and so on. And last but not the least, ensure that you're also including security analysis as part of your management tools, so that you're even doing sec DevOps as opposed to just DevOps, right? So again, trying to bring all of this together, if you were to just these are some stats from the State of DevOps report, and we look at 4 key metrics, right? When you want to analyze any DevOps implementation, we look at deployment frequency, change lead time, change failure rate, and mean time to recover. So teams that have actually automated their software delivery to a continuous delivery model, what we see is that deployment frequency goes from week to months to multiple per day, right? Change lead time actually goes from 1 to 6 months to 1 to 7 days. Change failure rate, it's going from 16 to 30% to 0 to 15%. Again, looking at a few more metrics, I spoke about mean time to recover. So if you have a fully automated process, teams are able to recover from an incident in less than a day. And this is for 77% of the teams that have those evolved processes. And similarly, you have better change management effectiveness. You can fully remediate security vulnerability in less than a day. And this is for 60% of the teams with a good DevOps process, right? Again, and last but not the least, you have when you have self-service and employee involvement, and this is for 13% of the employees that have been asked. And in fact, a survey that we ourselves did internally within Amazon, we see that the pipeline that we have built is one of the most loved services within Amazon and AWS itself. So that's something for you to take away. Putting a few references here, I will share this as the deck with the organizers here. But most of what I spoke about is documented in a lot of detail in something called an Amazon Builders Library. So you may want to look at some of the articles here in terms of how we utilize pipelines, how we do automated, say, hands-off deployments, how we do rollbacks, and so on. The other thing that you may want to look at, if you are already on AWS or even otherwise, is the AWS Operational Excellence well-architected pillar. And this has a lot of information like the questions that you need to ask for doing your operational readiness and so on and so forth. And also we have some documentation around how you can implement correction of errors. And this is also available as part of our well-architected pillar. So yeah, that's pretty much what I wanted to cover. And happy to take any questions that you may have.
So I wanted to understand at what point I understand that from the day one we should have the setup ready and we should have the complete DevOps and infrastructure in place. But at what point we should start looking at this as a serious part of the overall development process and not get into the trap of overscaling before the product actually reaches this stage. So, what do you recommend? Shall we take baby steps, or do we set up everything first and then focus on building the product?
No, take baby steps, right? You always iterate. So just like how you want to automate things, I mean, every time you automate something, it is going to increase your productivity, right? So look at your process and see, what is causing those bottlenecks, right? Where is it getting slow, and try and automate that. It could be infrastructure, it could be testing. You need to have a lot of pieces together to build this entire thing. So you could actually start the testing, right? Unit testing. That could be, I mean, many organizations don't even have that as a
Yes.
basic thing. So then make sure that you have integration tests. Make sure that you're getting the code review process in place, right? Once you have that, see, infra as code could be next, but again, infra is hard, right? If you can automate infra and you don't have to manually do a lot of these things, it kind of enables the team to really focus on what they want to do, right? Where are they
Building this.
delivering value? Infra should be your last thing in your mind, frankly, right? So see if you can kind of automate. See, there are tools are there, right? The tools are there, and it's fairly easy today to do many of these things as opposed to maybe 5 years ago. So yeah, look at where you're spending unnecessary work, and see if you can automate those out of your process.
Sure. Thank you.
Hi Satish, this is Jagan from FEMONK.
Yes,
Uh,
Jagan.
yeah, so you mentioned two-pizza team, right? So does that include quality assurance as well, or it's just the developers that you talk
No,
about?
QA is also included, right? There is no separate QA. So the developers themselves, that's what I said, right? You still go through a code review
Yeah,
to make sure that the code can be deployed, and it becomes easy because the changes are fairly atomic, right? So that's one thing. Secondly, you cannot push your code and get past the code review unless you do your unit testing. You have all your unit tests, you have the integration tests, and you have also instrumented the code as per standards, right? So that kind of enables the reviewer also to kind of go through a checklist and make sure that hey, these things are here, and let me get this through. And once it is through, everything is then automated beyond that, and you don't need like a large team looking at individual features, right? And see, again, this works well if you have the right functional tests and the integration tests also. So ensure that those are also available.
yes, of course. Yeah, thank you.
Satish, one more follow-up question. This is Anurag again.
Yeah.
Currently, I represent a brand called Stolo. So I'm the founder of Stolo. Stolo is an option trading platform. We have close to 22,000 users, and we deploy almost every day, the front end separately and back end. The front end, what we have done, we have used CloudFront and we deploy to S3 and we serve it through CloudFront. Now, what would you recommend if we have to do some A/B testing, or to certain user we want to release first, and to certain users, like what you mentioned you do with availability zone, right? So if we have to architect something, what would be your recommendation?
There are multiple tools out there in the market.
Okay.
See, at AWS, we do have one tool that is called CloudWatch RUM, Real User Monitoring, which is not available in the region at this moment.
Okay.
So it is part of CloudWatch itself. And we also have CloudWatch Synthetics and so on and so forth, which can be used, but not rolled out in the region. So what I would
Okay.
recommend is to look at a partner tool. There are multiple out there, right, that allows you to do A/B testing today, and see if you can utilize any of those.
Sure.
Yeah, I hope it was useful, and reach out to me. I think my email is sathari@amazon.com, or you can just connect with me over LinkedIn, and I'll be happy to take any questions that you may have.